concept, which is precision error.
I mean, we all know when we take our kids' temperature in their armpit, for example, it doesn't always come out to be the same. And you measure it one time and then it's 1 degree lower than the next time. In this ice water bath, for example, you can see that where I place the probes of each of these 2 thermometers, sometimes it's right in between 2 ice cubes, sometimes it's down at the bottom. And that's the same thing when you measure the temperature of your body in your armpit. Sometimes you got it down there in your armpit, sometimes you got it up and you have your undershirt. So it's slightly different. That sort of error, that sort of difference between repeated measurements, or if you had 2 of these probes, between the 2 results, that's the error of the population. So if in terms of your armpit, if you measured the temperature at every place in your armpit, you would have a population of temperatures. In this case, if we measured the temperature at every single point in this ice water bath, we would have a population. Now, the whole point of stirring this, as anybody who's calibrated a temperature probe knows, is because you're supposed to keep stirring it around so it's as homogeneous as possible. So your population, the differences in the different temperatures in your population is really low. You have, ideally, one temperature, 0 degrees, in your whole ice water bath. And that's why you have this mixture of ice cubes and water, and you stir it around and try to keep these little probes. But you know what? It's always a little bit different, isn't it? 1 degrees, 2 degrees. So what is that?